Okay. So before we continue, let me summarize. What we are going to do in this lecture is continuation to Nyquist. This is the last example which we are going to give in Nyquist, where I have, this is the open loop system. It has 3 poles, okay? And we said, in order for us to investigate the stability using Nyquist's criterion, first of all, I will, locate the poles of the system in the S-plane. Since tau 1 and tau 2 are positive, so all of them, they are going to be in the, on the negative part of the real axis. And then because I have a 0, because I have a pole at the origin, then I, if I want to take the Nyquist contour, I must start from something above the 0. I cannot pass through the 0. So if I will start from 0 plus, I'll go all the way, let's say, omega 2, be omega equal 1, 10, infinity. Then go all the way back and cover the entire right half plane, go to the negative frequency and stop at 0 minus. So let's now sketch the area from 0 plus all the way to infinity and back to 0 minus. We are saying, okay, let me start with 0 plus. With 0 plus, I will have magnitude equal to infinity, and the phase is going to be minus 90 minus something. So I will be somewhere in here. This is the correspond to omega equal to 0 minus, where this is
0 plus, you mean?
Infinity. Okay, now
0 plus, Doctor.
Sorry, 0 plus. Now we increase. We go, let's say, ultimately to infinity. So L of J infinity.
Magnitude 0.
Wait يا عبد الرحمن, let me أبغى الشباب جزاك الله خير عبد الرحمن, يعني بصراحة great على المشاركات, بس to give the opportunity for other people as well. عبد السلام. Okay, عبد السلام, at infinity, what will be the magnitude?
0.
Exactly. What about the angle?
Minus 90.
Exactly. And then? What about this one? Omega could go to infinity. Tan inverse of infinity.
0.
No. At t, the tan at infinity, it means that the angle will be 90. Tan of t is infinity, isn't it?
Yes.
So minus 90 and minus 90.
Minus 27.
Okay. So this is equal to 0 an angle of minus 270. So basically, as I increase omega, okay, you can take omega in between. It will go in this way and it will come tangential to the minus 270. So this is omega equal to infinity.
Oh, Doctor?
Yes.
How did you know that it will cut through the second quarter?
Yes, how?
Look. Well,
why it's not going directly to the minus 2, like what we have, we had certain examples. Directly we go to the the origin without
look,
cutting
but the angle is important. You will go intentionally to 270. Where's 270?
Minus 270 it is 90.
It is 90. So basically, it is going to be tangential to this point, to this line. Okay.
The same, Doctor. We can go to the origin. without cutting. We can go without cutting.
No, how can, tell me, how? Show me.
Like what we had examples actually. You go to the, you know, to the, it will be, maybe this is 180, right?
180 or exact? No, there is
Minus,
no way.
minus 180, I see now.
No
yes.
way. From here you go to 270. You must cut the real axis. But anyway, Abdurrahman, look, this is from experience.
Experience, yes.
Or have a doubt, take a point, take any omega if you know tau 1 and tau 2 exactly, okay? Take a point, set omega equal to 1, 10, 100, and see where are you.
I see.
Okay, now let's take the mirror image of it. So the mirror image is going to be like this. And this is 0 minus. Okay?
I see.
So first of all, let's
When did
know, how do I close between 0 plus and 0 minus? We said we start from 0 plus, go all the way to infinity and come back in the negative, and you reach at the 0 minus. Now around the origin, okay, around the origin, take around the origin, set, let S equal to rho e to the j theta, because I want to follow the arc in here around the origin. I want to exclude the origin. So if I do that, then my approximation L of rho e to the j theta equal to, okay, K over rho e to the j theta times tau 1 rho e to the j theta plus 1 rho, sorry, tau 2 e to the rho e to the j theta plus 1, which is approximately, look, this term I can approximate equal to 1 and this term equal to 1. So we'll have K over rho, which is basically infinity. Infinity, an angle of minus theta. Okay, so now I make a table, theta and the phase, which is minus theta. Look, I'm at this point at the minus 0, at 0 minus, sorry. What's the coordinate? What will be the coordinate? The coordinate is going to be rho, which is a very small number, with an angle of, what's the angle?
Minus 90.
Minus 90. So this is minus 90. If this is minus 90, the phase angle of the system in there is going to be 90, because this is minus. Minus minus will be plus, which means that I am at this point. I'm here. Now, let me move in this direction and let me take the 45, angle of 45.
معلش يا دكتور لحظة بس. الحين at 0 minus, it is minus 90.
Yeah, the position, how do you, okay. The coordinate, look at this one. Okay. I'm giving you, okay, let's say, okay, the magnitude, okay, the magnitude is, let's say the magnitude equal 0.001, phase equal to minus 90. Where do you position this point?
Well, it is in the fourth quadrant.
It's in here. This is the point.
Where is it? I cannot see.
This point. Very small magnitude, rho, an angle of minus 90. This is, look, this is 0, this is minus 90.
Yes, yeah.
Okay.
Yes.
So this is the point.
So now we are now working on the S-plane because we have two planes now. So
Yes.
these
And
are
so in
confusion.
the S-plane, it's going to be, okay.
Because in the S-plane,
Very
0
small
minus.
number, magnitude, and angle of minus 90.
Yes.
In the G of S-plane, the magnitude is becoming infinity because I'm dividing by a small number, and the angle is going to be 90.
Yes. So this is the confusion. Yes.
Now I am moving. I'm keeping the same magnitude, but I'm changing the angle. So if the angle will be minus 45, it means that I reach this point here in the middle. The angle in here will be what?
45.
And where do you locate the 45? It's again the magnitude infinity. But where is the 45? Which quadrant?
First quadrant.
So I'm moving in this direction.
Yes.
Let me keep the magnitude small and the angle equal to 0. Where is that point? It's going to be this point.
هي خلاص واضحة يعني.
If it is 0, then it will be 0 in here, and then I will continue. So this is what I have. Now the question is, what's n equal to?
Now we need to know this point, Doctor, right?
Exactly. Now we have to know
the point of cutting.
Point. I have to know this point.
Yes.
Okay. So this is. Okay, so I have to know this point. Any suggestion? How do I find this point?
Any suggestions?
Find when the angle is minus 180.
Exactly. So basically, look, I am moving in this direction. So in here, this is the angle of minus
180.
So if I set the phase, which is this one, to minus 180, that will give me omega. I will use omega in finding the magnitude. And
basically minus 180 or plus 180, it is the same.
No, it is minus 180. If you get plus, it will be, because look, you are starting from minus 90 along this direction. So when you reach here, you are at the minus 180. Okay. Sometimes you
Doctor.
Mathematics.
Doctor.
Fadal.
But if we start from 0 minus, we will go from a certain angle to positive 180, right?
If we start from 0 minus.
Yeah, we will go to plus 180.
Yes. Oh, you want your direction down? Yes.
يعني قصدي دكتور minus 180 or plus 180.
Don't complicate things. This is the contour which we are taking.
Minus 180. That's it.
One. Okay.
Yeah.
So if you follow that one, this is the arrow where the increase in the frequency. So
right.
Reaching the minus 180.
Right.
Okay, there. Okay.
Okay. Now, let me clear this.
Now, how can we find minus 180?
Just 1 second. Okay. Remember, the phase. Okay. Okay. L of j omega equal to, we said K over the magnitude omega root of omega tau 1 square plus 1 root of omega tau 2 square plus 1 angle of minus 90 minus tan inverse of omega tau 1 minus tan inverse omega tau 2. Okay. So we said set the phase equal to minus 180, which means that I have minus 90 minus tan inverse of omega tau 1 minus tan inverse omega tau 2 equal to minus 180. And then I want to determine the frequency. Okay, let me simplify. Take the minus 90 to the other side and multiply by minus 1. So that will give you tan inverse of omega tau 1 plus tan inverse omega tau 2 equal 90. Any problem here?
No.
Okay, now there is from mathematics, there is,
This has to be by over 2.
okay, this is pi over 2, but okay, there is formula from the trigonometric identity, it's a trigonometric identity, tan inverse, let's say, of, let's say, x plus tan inverse y equal to tan inverse, I can combine the two. Okay, x plus y over 1 minus xy.
Yes, yes, yes.
Okay, we use this one. If we use it, so I will have tan inverse of omega tau 1 plus omega tau 2 over 1 minus the multiplication, so it's going to be tau omega square tau 1 tau 2 equal to 90.
ممتاز.
Okay, now when, okay, tan 90 infinity, which means that when that will happen?
يعني لما يكون 1 minus omega square tau 1 tau 2 0.
Exactly, when the denominator equal to 0, which means that 1 minus omega square tau 1 tau 2 equal to
0.
0, or omega equal 1 over root of tau 1 tau 2. So this is the frequency where I reach, okay, so this is the frequency at this point. Now, let me determine the magnitude. Okay. This is what I have said. Let me clear. Okay. In order to get this point, just substitute in the magnitude. Okay.
Good.
Magnitude? Remember the magnitude. Let me.
So if 1 over root of tau 1 tau 2 is greater
okay.
than.
Let me. Okay. Remember the magnitude.
Yes.
The magnitude
But the magnitude, doctor, will be plus.
Equal to, look, k over omega root of omega tau 1 square plus 1, and then we have root of 1 plus omega tau 2 square. Now we said omega at this point equal to 1 over root of tau 1 tau 2. Substitute. So what do I get? K over, okay, 1 over, so it's going to be 1 over root of tau 1 tau 2. Do you agree?
Yes, yes, yes.
Root of, now, this is omega tau 1, the whole thing square. So
it will be tau 1 over tau 2.
Exactly. Tau 1 over tau 2.
Plus 1.
root of
Same there, but tau 2 over tau 1.
tau 2 over tau 1 plus 1,
Yes.
which is equal to, this is basically, okay, let me put this one k, and this will go in the numerator, tau 1, tau 2. Okay, and in here I have,
2 plus,
okay, root of tau 1, tau 2, and I will have tau 1 plus tau 2. I think there's no need for the, because it's
why is this?
okay, we'll have,
No.
we will have tau 1 plus tau 2. So this will go together, and what we will have, and the tau 1 will go up, so we'll have tau 1, tau 2, k over tau 1 plus tau 2. And this is basically what we have in here. This is the magnitude. So this is the point. Now, any question here?
Yes. So here, Doctor, it depends on K and the taus.
Exactly. So is the system stable or unstable?
Definitely unstable.
If K, tau 1, tau 2 over tau 1 plus tau 2 greater than 1, if it's greater than 1, how many, what's n equal to?
It's unstable, sir.
N
Yes.
equal to 2, which system is unstable. Unstable.
طبعا تو عشان two circulations عندنا دكتور صح؟
Exactly. Two encirclements.
Or encirclements, yeah.
If K, tau 1, tau 2 over tau 1 plus tau 2 smaller than 1, I'm not encircling the 1 anymore, n will be 0, stable. Okay, so in this example, we have to figure out this point. We are not, it's not enough to go to the omega equal to 0, omega equal to infinity. We have to have this point. Any question?
No, it's clear.
Okay, now let me continue in this thing, and we talk about,
دكتور
تفضل.
نايكوست هو اخر شابتر في الماده هذه او في بعده؟
لا لسه بعد عندك الديزاين.
وبعد الديزاين في ايش يا دكتور؟
ان شاء الله سلامتك.
سلامك الله.
شو ما تبغى نخلص سمستر ولا ايش؟
خلاص يا دكتور مضغوطين الله المستعان.
الله يكون بالعون. طيب, what we want to discuss now, the concept of phase margin and gain margin.
هذا لسه تبع النايكوست.
هذا تبع النايكوست وايضا تبع البودي. نتكلم عن البودي الحين. الكلاس هذا نتكلم عن النايكوست, والكلاس الثاني ان شاء الله how do we obtain those من البودي plot. Now, first of all, we talked about relative stability. When did we talk about relative stability?
At the beginning of the Routh-Hurwitz criterion introduction.
Exactly. And how did we define the relative stability?
We basically make a shift S plus A or S minus A. Sorry.
So
shift to the left, so S plus.
Yeah. In a sense, how far we are from the J omega.
J omega axis.
But the measure in there is, it is not very accurate.
And it's trial and error.
Trial and error. Now, we would like to talk about the relative stability.
Systematic way of doing it.
Okay, precisely. For example, if I have a system, let's say, similar to the system which we had before, similar to the example in here, assume I'm having only the positive frequencies. The negative will be, you know, will be the same. Okay. So basically, if this is the -1, how much I can add to the system gain before I reach the -1. That will give me the measure, okay, how much I can move, how much I can add again in my system, okay, before it becomes unstable. I can calculate that one exactly.
Mhm.
Or if I have a system like this. So the system to start with is unstable, isn't it?
How can we reduce the gain such that the system becomes, or drive the system to stability region?
In another way, the phase margin, gain margin will give you relative stability measure, and also in the body plots, you can determine the stability of the system from the gain margin and phase margin.
دكتور
Yes.
ليش تقول عن system unstable if it encircles -1 يمكن B equal to -1 قصدي B يمكن equal to 1.
Look, generally speaking, this is the way. Think about it. Okay, you can look. The minus.
معلش يا دكتور ايش سؤال مادي؟
السؤال
قصدي
ليش انه ليش if you are moving in the direction you will be yeah, if you include the -1 it will be why it's unstable. Maybe what he's saying could be n will be in the negative and then it will negate the other. No, look.
Oh, yes.
No, look, wait.
Valid point.
No, the -1 point, think about it in the root locus. What does it correspond to? Do you know what it corresponds to? The -1?
0.
No.
The asymptote.
Say that again. Say that.
The asymptotes.
Not the asymptote, no. Look, it is 1 plus, if you remember, k g of s, h of s equal to 0. It's correspond to the j omega intersection. It is where the system becomes marginal stable.
Yes, right. Because
Okay.
kgh will be -1.
Okay.
So the open loop gain will be -1. Yes.
So it is correspond to this point. If you increase, it means that you go in this direction, and this is become unstable. So this is the same thing. If you think about it, if you relate this one also to the body plots, the body plot. Remember, take this
The
one.
body plot it is a 0 line.
It is the 0 dB line.
dB line.
It is the 0 dB line. Okay. So look, once you know enclose the -1, usually your system is empty.
يعني دكتور الحين الفكرة إنه لو if we you know the encirclement is in the counterclockwise, so it will be minus, right?
Yeah, minus, but it depends on yes, it could be minus. It could be.
And if it's minus and we have one ball from the S-plane, so
But you don't know where is okay. You don't know where is your pole. Maybe they are inside maybe what you are saying. Okay, I could have a system like this. And let's say in here, I have a pole in here. And this pole will give me, okay, suppose, okay, let me use the same thing, but a pole in here. The pole,
see.
okay, if I have encirclement minus, and it will negate it by this one, the pole, this is plus, and this becomes stable.
طيب هنا دكتور question. الحين لو if I have encirclement counterclockwise, so it is minus.
Okay.
And I have only one ball at the origin. If I include this ball, the system is stable. If I exclude this ball, the system is unstable.
But yes,
So because you mentioned that.
Look, you have to be careful. I mean,
I see.
The encirclement, it's related to the, you know, to your your contour.
I see. So this is an impossible case, right?
Okay. It doesn't, but you know, if you are, okay, if what you are saying, suppose I have a system in here, I'm including this one,
Yes.
okay, so P equal to 1.
Right.
For the system to be stable, N equal to -1.
Right.
To be stable. Otherwise, if N equal to 1, if it is in the clockwise direction, the system will become unstable.
And if it's a stable, so when I exclude the pole, N will be 0. To be consistent.
Yes, yes, yes.
Mhm.
So anyway, look, the concept of the phase margin and gain margin, okay, this is basically what we are going to do. The gain margin and phase margin, we could obtain these two quantities from Nyquist, and we can obtain them as well from the body plot, and we'll come to the body plot a little bit later. Now, the way it's been defined, okay, the gain margin is a change in the open loop gain expressed in decibel required at -180 degree of phase shift to make the closed loop system unstable. And the phase margin is how much I can add a phase to the system before become unstable also. Let me translate this wording into graphics. Usually with the graphics, it will be more crystal. Suppose I have, similar to what I have said at the beginning, this is the positive direction of the positive frequency. So suppose this is the -1 in here. So the gain margin is basically, if I assume this is A from here to here, this is the magnitude A, and suppose this is X from this point to this point, X. So the gain margin basically, the gain margin equal to X, which is equal to, so basically, okay, gain margin equal to X, but X, okay, X times A equal to 1. So what's the value of X, which will make, you know, I mean,
1 over A, 1 over A.
exactly. So X equal to 1 over A, and this is my gain margin. Put it in dB, it's going to be, you know, I mean, take 20 log of X will give you 20 log or -20 log A. So this is the way. In order for me to find the gain margin, let me figure out what is this frequency, substitute, as we have done in the previous example, substitute in the magnitude, and that will give you, you know, what is A at that point. So how much I can, what factor I can multiply A with to bring it to the -1, where the -1 is the instability or the critically or the marginal stable point. Is it clear?
دكتور
Yes.
والله it's not clear دكتور.
الحين دكتور الجين controls the radius of the contour or ما فهمت.
ايش؟
لو زودنا الجين الدائرة هذه بتكبر أو ما بتكبر؟
الحين لحظة دقيقة يا شباب. الحين focus. Let me resketch the game.
Slowly دكتور.
Okay. Slow motion.
Slow motion.
طيب. Okay, هذا الجي اوف اس plane. Plane. We'll take one at a time. Suppose I have this.
الجي اوف اس بلين اللي هو الاف اوف اس نفسه ولا ايش؟
Yeah, الاف اوف اس plane.
Sometimes you call it L of S, G of S يعني.
It depends. تكون L of S لما I have G of S times H of S.
I see. So it is the open loop base plane.
Yeah, okay. So suppose this is what I have. And suppose this is the -1. What I'm saying, the gain margin is how much I'll multiply my system to bring this point to the -1.
ممتاز.
I want to bring this point to the -1. which factor I'll multiply this point to go to the minus 1.
1 over that.
Okay, so if this is A, if this is A, the magnitude A, then my gain margin equal to,
1 over the X intersection. Yeah.
okay, 1 over A.
Mhm.
This is
مظبوط.
normal, multiply, if you want it in dB, take 20
Log
log.
the magnitude. Yeah.
Any question, is this clear?
Yes. Now clear.
Yes, thank you.
Okay, now let me come again. I need the phase margin. Again, G of S plane.
Mhm.
Okay, sigma or real and imaginary. And again, this is what I have. Okay,
ممتاز.
suppose this is the minus 1. This point is minus 1. Okay, to get the phase margin, first of all, okay, to get the phase margin, I have to get, look, for the gain margin, we set it equal to minus 180. And here, let me sketch so what I'm sketching. What is the radius of this one?
A
No?
or 1?
1.
1, 1, 1.
1.
Yeah.
A unity. Okay? Then find what is the angle at this intersection when omega equal to 1. No, not omega equal to 1, sorry. When the magnitude equal to 1, find omega. Call it omega CG. Find omega. Look, in here, we set the phase equal to 180. Now, let me make the magnitude equal to 1. And I can find find the frequency, can I?
دكتور ايش قصدك نخلي الفيز 1 minus 180 في الجين؟
كيف؟
في الجين margin. What do you mean by making the phase minus 180?
This is the point. Remember the point. I am moving from here in this direction. What is this point? What's the angle in here?
minus 180.
Exactly. That's what we are saying.
Oh, okay.
Now I'm saying let me find where the magnitude equal to 1. Find the frequency in there. Then solve and get the phase. Get the phase. This phase. Or from here to here. This is the phase. The question is for the phase margin, okay? In the phase margin, how much I can rotate? I'll bring it to the 180 degree because I want to bring it to the minus 1. So how much phase I can add in here, okay, to make it unstable. Can I call in 2 minutes? Okay. So this is the concept of the phase margin. How much I can add from this point, okay? I'll find the phase in here, and then how much I can add so that I'll bring it to 180. And here you accept, you increase the gain. Now we increase the phase. صعب عليكم.
والله disastrous.
Look.
I need example.
Just 1 second. The way, okay, so basically to get the phase margin and gain margin, first of all, I define the two frequencies. This is, I call it omega CG, which is the gain crossover frequency. It means the gain at which the magnitude equal to 1. And CP, it is the phase crossover frequency. It is the frequency where the phase is equal to 180 degree. Okay? And you just find them. So set the magnitude equal to 1, find the what we call the gain crossover frequency. And set it equal to 180, that will give you the phase crossover frequency. Once you get this one, okay, you can get the phase margin is going to be 180 plus the phase whatever at this frequency. The gain margin is 20 log of 1 over this quantity evaluated at the CP. Okay, let's stop in here, and I think we'll continue on Saturday. We restart again on the phase margin and gain margin. Okay? So we'll see you on Saturday. Any question before we stop?
Thank you, Doctor.
Okay.